Welcome back to Neuron short number 3 about the bridge variants. In the previous Neuron shorts, I explained that the functionality of the neuron processing boards is defined by the software and that these software variations can be divided into different categories, such as bridge, convert, compress and protect. In this 10-minute video, I'm going to focus on the bridge category, which are designed for bridging SDI to and from IP or bridging one IP format to another. On our website, the bridge group is described as multi-channel AV over IP transceivers developed for use within low latency and high bandwidth IP networks. In combination with the SDI expansion module, the bridge can process up to 32 video signals and multiple channels of audio, acting as a unidirectional or bidirectional bridge in hybrid applications. Each of the 32 processing paths is capable of frame synchronizing, proc-amped and audio de- or embedding. The bridge also performs well in IP-to-IP setups, being the link between ST2110 and ST2022. Let me explain the term transceivers first. The word transceiver is a compound of the words transmitter and receiver. It means that the bridge variants can be used as input, SDI to IP, output, IP to SDI, or both, some channels from IP to SDI and some channels from SDI to IP. The word is plural because there are several software versions available in this category. Which version can do which kind of bridging can be derived from the software names. All bridge version names start with a B, which stands for bridge, followed in most cases by an S, which stands for SDI, and a G, which stands for gateway. Behind these three letters, indicating the category and the functionality, there are 4 numbers, indicating the number of IP output and input streams. The BSG1616, for instance, has 16 IP output streams and 16 IP input streams, while the BSG2408 has 24 IP outputs and 8 IP inputs. And the BSG3200 has 32 IP output streams and no IP input stream. So the BSG3200 is intended to be used with the SDI expansion board to have 32 SDI inputs bridged to 32 IP streams to enter your IP infrastructure. The BSG2408 with SDI expansion can convert 24 SDI inputs to IP and simultaneously convert 8 IP streams to 8 SDI outputs. The BSG1616 can simultaneously convert 16 SDI inputs to IP streams and 16 IP streams to SDI outputs, and so on. Behind the 4 numbers indicating the IP I/O, there's usually a dash followed by more digits. These digits indicate the configuration of the network interfaces. 2Q6 stands for 2 times QSFP, so using the QSFP plus interfaces, with ST2022-6 redundancy. 2Q7 stands for 2 times QSFP with ST2022-7 redundancy. Remember that you can always reprogram your processing board at a later stage to change the number of I/O, the network interface configuration, or to change the functionality entirely by programming a different software version. Before zooming in on the various processing paths of a BSG, it is important to understand the difference between the ST2022 IP format and the various ST2110 standards. Simply put, in ST2022, all video, audio and metadata is kept together in an IP stream. Think of it as an SDI stream with video, embedded audio and all auxiliary data in the video blanking all together chopped into IP packets and streamed over the network. In ST2110, the video, audio and auxiliary data is distributed in separate streams. An ST2110-20 stream contains only the video. ST2110-30 streams contain only audio. ST2110-40 streams contain metadata, etc. Now, if you want to convert an SDI or an ST2022 stream to ST2110 streams, you need audio de-embedders to de-embed the audio from the video and insert it into separate ST2110-30 streams, while the video goes in an ST2110-20 stream. So processing paths which are intended to convert SDI to IP, where the IP outputs might be configured as ST2110, require de-embedders. Going the other way, so from IP to SDI, you need to be able to receive an ST2110-20 video stream, as well as one or multiple ST2110-30 audio streams, and merge them together into one stream using audio embedders. So processing paths intended for conversion from IP to SDI require embedders. That's exactly how we developed the BSG variants. The BSG 1616 is intended to bridge 16 IP channels to SDI using audio embedders to make it possible to insert audio from ST2110-30 streams into the video, and simultaneously bridge 16 SDI inputs to IP streams using de-embedders to separate the audio from the video when converting to ST2110. If we look at the interface of the BSG 2408 for instance, you see that only the first 8 paths have embedders, so intended to be used for IP to SDI or for ST2110 to ST2022 conversion, and the other 24 paths have de-embedders, primarily used to go from SDI to IP. Of course, you're free to use any IP standard you'd like on your outputs, so if you want to convert your SDI inputs to ST2022, you can simply change the media type of the IP output stream and ignore the positions of the embedders and de-embedders if you don't need to shuffle your audio. Besides the embedders and de-embedders, each processing path has individual frame sync and delay settings, as well as color correction settings for RGB, YCRCB, clip and hue corrections. The paths with embedders also have additional audio processing, like gain and phase settings for each individual audio channel. The BSG can bridge UHD signals as well, but you have to make sure that the input format is equal to the selected output format, since the BSG card cannot up, down or cross-convert the video format. So if the input is 4-wire 2160p50 square division, make sure to select 4-wire 2160p50 SQD as your output format as well. Otherwise, these warning signals will start blinking and your output will be invalid. Using this interface, you can freely assign SDI or IP inputs to the various processing paths and assign the processed signals to one or multiple SDI or IP outputs. Let's look at the IP video and audio I/O tabs. Oh, by the way, please note that the interfaces I'm showing here are all subject to change with every new release. But although you might find some additional settings or statuses in these GUIs in the future, the general user experience of these interfaces will remain the same. On the IP Video I/O tab, you can configure your IP inputs and output streams manually. I deliberately say manually because these parameters can also be controlled by IP routing systems like Cerebrum using the commonly used NMOS ISO5 protocol. If you want to change the IP address and port of any of these inputs, you can either change them in here or go to your router panel and change the IP source of that IP destination, just like you were used to in the SDI domain. Here you can also see the two-legged approach of all the input and output streams. Each output stream consists of 2 identical feeds which a receiver can subscribe to. When the card supports DAS7, indicated in the card name, the receiver can choose to read leg 1 or leg 2 per IP packet, so in case there's a bad packet in leg 1, the identical packet of leg 2 can be used. When a card is DAS6, it can still receive 2 identical streams, but only choose to read the backup stream when the stream in the first leg is completely gone. It does not switch per packet. I don't want to turn this video into a tutorial too much, so I'm just going to mention that you can easily copy and paste specific output IP settings to input IP streams, that you can check which stream is on which SFP interface, and that there are handy tools to automatically fill in the IP and port addresses of all output streams for quick initial configuration. On the Audio Paths tab, you can see where all the audio channels that are in the audio matrix come from. So you can see the audio from the de-embedders coming in here, and the audio from the ST2110-30 IP audio input streams coming in over here. If you have the MADI option, you will see the MADI inputs going into the matrix as well. You can also set audio delays and select whether you want to enable the 64 channel mode for all ST2110-30 input streams by merging 4 streams to 1. Which audio channel is embedded into the SDI or ST2022 streams is set here in the embedder settings of each path. which audio in the matrix is inserted into the ST2110-30 audio output streams can be configured here on the IP Audio I/O tab, where you can also change the channel count of each stream and change the gain and phase settings of each individual audio channel. Selecting which audio channel goes where can also be configured in the Audio Matrix tab, where you can route all 500 plus audio sources to any channel of the embedders and IP audio streams. If you want to know more details about the bridge cards, please go to our website and download the latest datasheet. You can find it under the Products and Components section and the Neuron Products section on the Neuron website. Thanks for watching again. The next Neuron short will be about the convert cards. See you then!